Hello, so this is the part where we're going to be learning networking, and I need you basically to understand some of these concepts of networking and classes and how this overall works. So as you can see, we have three classes of IP addressing. Now D and E are reserved, they're not really used in networking in terms of like normal networks. So there's two classes, as you can see. There's three different IP addresses. Now, your knowledge of IP addressing is possibly very, very short. So IP addressing has there's a lot of functions, but let me say basically the variants. So there's a variant one, which is public IP address, and there's a private IP address. Your private IP address, I'm pretty sure I explained this, but I'm going to explain this again, just in case you maybe missed something. So the private IP address is something that is basically used in networking and internally in a network to communicate with devices, and used in devices to basically know where to send data, where to retrieve data from, and where's basically where the device is, and used in, for example, ethical hacking as well. Public IP address is used basically your internet service provider's IP address. You should not expose the IP address because it's something you basically can get identified by. Your IP address traces back to your location. You can easily check your IP address. Some of the IP addresses are private, but most of them are not. So which means if someone was to connect to your network by a public IP address, you can trace back their location, right? So as you can see, we have some classes. So we have these obviously are internal classes. They're private IP addresses. So this is not your public IP address, right? So as you can see, we have ABC, and this is what we're going to focus on. D and E are reserved for networking, but this is something you need to know about as well. So class A is basically goes about reverse. So class A is the biggest network of them all, B is medium, and C is the smallest. C networks are basically the IP addresses you're going to have in your home network because they're the smallest networks. Now the IP addresses obviously may be a bit different, but usually what your IP address maybe is 192.168.1.1, 0.1, 1.0, something like that. That's your default gateway address, which means your router address. If you put that address in your browser, what you're gonna get is basically you're gonna be connected back to something called default gateway, which is your router's sort of homepage, if you want to call it that. Now, there's something I need you to understand. So class A can have about 17 million hosts, because basically all you do is change the subnet mask, the IP range, the IP address, and you're able to basically have 17 million IP addresses. So as you can see, this is the network address and host ID. You just need to change these values, and all you have is basically brand new network, a subnetwork we can call it, and you're able to have 16 million or 17, well, it goes up to 17 million nearly. So let's just call it 17 million. It's like 17,700,000 something. I don't know the exact number because it's not really something I need to worry about. You don't need to worry about either. You just need to know that the specifics of each network and how many hosts it can have. So the network ID class A is basically, for example, let's make it 10. Let's make it 10, 10, 10, 10. That would allow us basically 17 million hosts. Obviously, the IP address needs to change. Not necessarily that network would allow us to have 17 million hosts. It's something that's a bit hard to explain. You just need to sort of go about and try and understand it. It won't take you a day. It will take you a couple days, weeks to understand this, right? Class B can have 65,000 hosts because the subnet mask changes, right? As you can see, class B network ID, host ID changes, right? So it completely changes how this is looking. So we have two network basically bits. These are called bits. Each bit has 8 bits of IP addresses. Sorry, 8 bits. Sorry, each bit has 8 bits of binary. So it'll be like 11111, 11111, right? Add all the way to 8, and that'll be 8800, which means it'll be 16 /16. You don't need to worry about prefixes right now, but it's just something to take a note of. Class C can have 254 IP addresses, hosts, sorry. Well, technically 254 usable IP addresses, I was right. And it can, why now, if you go on the internet, we'll say 256 altogether, but 254 usable IP addresses. So this is important to keep a note of, that every network you need to take away 2 from, because there's default gateway and broadcast address, right? So these are two IP addresses are reserved in each network, and these are not usable hosts because they're reserved for a special purpose. So these are the 2 things you need to take away from, okay? So that's technically it for basic networking. You basically will understand more the more we do. I just need you to understand. Now because this is a tutorial, this is something that not everybody will understand. And there's also a loopback address, but you don't need to worry about it either for now. I will be using class C because it's the easiest to do. So let's get to Cisco Packet Tracer and let me explain the rest. Okay, so we're back to Cisco Packet Tracer. Now what I want to do is basically set up the network. Actually, give me seconds, I'm just going to load the old network. Right, so as I said, as you can see, we have a network. As you can see, 196.168.10.10.10.11. The IP addresses are not set for this. Are they set this way? Yes. They're not working. Let's see, why is it not working? Sometimes you can get some errors. The reason is because there could be some problems with the DHCP server, or yeah, so the whole DHCP failed. Give me a second, I'm gonna check out why. So basically the server had to warm up a second, it didn't work because I just launched this packet tracer, so that's the reason. So we're back into packet tracer. As you can see, these have default, these are IP addresses that I have reserved. As I said, I like to reserve 10 to 9 IP addresses for default, for the services, to basically separate them from the whole network. So all the way to, how many hosts does it say on the server? We should say 246. So we can have 246 more hosts on this IP address. Actually, it'll be 244. Yeah, there'll be 244. So we can have 244 maximum users on this network. And what we can do is we can actually set up another network, and let me just get the second server. Now what we just need to do is basically change the IP addresses. So what we're going to do is config, we're going to desktop, and we're going to change the host, sorry, the network address, not the host, the network address to, let's do 20. I like to separate about 10. Now it really doesn't matter what you do, as long as you don't change to 192.168. Technically, if you put a router, it will still work, but I don't want to basically mess everything up, so I'm just going to do the same thing for the server. And we need to remember, you need to change the DHCP for this to work, right? As you can see, it changes itself. If you just press save and you go to PCs, just click DHCP, everything should change. As you can see. Oh, actually, we just need to change one thing. I forgot about it, because it will give the, as you can see, which just give the wrong IP addresses and it makes everything up. So let's go to change again. There we go. So as you can see, it changes everything. Oh, it changed automatically. That's very good. Usually what you have to do is come to IP configuration and just click DHCP, change it from DHCP to static and back to DHCP, but that's not all the time. Okay, so as you can see, we have 2 networks. Now, obviously, we can't just go to this computer and ping the server, for example. We can't just go and ping the server because they're not connected, because this is obviously 2 different networks, because they have 2 different IP addresses, and that the host part is different and the network part is different as well. So what we need to do is buy the router, take the router. We need to get the router to 1941. We can use basically anybody. Remember, I suggest I recommend this router. The reason is because it's very easy to configure, plus not all of these work, sort of. I've tried others before, they don't work as well as this one. So automatic switching to switch, let's just make this a bit here, there we go, so it's a bit separate. Now as you can see, we're connected. Now, because we're still not connected, we've not configured it correctly. As you can see, it says red. It shows us a red little triangle. Doesn't mean it's working. What we need to do is go to the router. We need to go to configurations. And what we need to do is basically turn it on and put the IP address of one first of all interface. So as you can see, if you turn it on, as you can see, the interface is left side. So what we need to do is put the IP address, which is 192.168.10.1. And the changes, as you can see in the command line, which I'm going to show you how to do as well in the next part. And if you go to config on the other section, let's just do it this way now. Turn it on and put the IP address. And as you can see, it should work now. So if you go to your PC1 and now you try to do the same command, you should get a reply. Now you might get a first error request timed out, but the second reply should work. Now if it doesn't work, that means there's a problem, which is absolutely normal. It happens. Oh, sorry, it's not connected. That's why I see it takes a second to connect. Let's just speed this up. There we go. And let's just request again. And it should work, because obviously, if not, there you go. So there's a reply. Now the first package, you can see there's lost one. That's absolutely normal. If you request again, there should be, as you can see, it should be 100%. So it takes less than a second to travel. And sometimes it doesn't work. What we need to do is go to, if it doesn't work for whatever reason, for example, as you can see, if you go hover over the router, sometimes it doesn't work. The reason is, there could be a lot of reasons, but one of the reasons is VLAN. So VLAN is important because it helps in communication and organization of the network. So what we need to do is basically, now you should be in config. If you're not in config, for example, I'll quit config right now. If you just press enter, press en, conf t, which stands for configure terminal, and you go to interface VLAN 01 or 1, and you press and you type no shot, and you press just enter it, and you go over. As you can see, it says VLAN up, which basically allows us to organizes the network for us. And if you go to, for example, let's go to PC9 and let's ping the network of ping 192.168.20.12, for example. And it should take a second to. There you guys, you can see we're going to reply. Now this is obviously, as I said, it's absolutely normal for the first request to be timed out. But if you send a second request, it should get a reply straight away. So this is how basically networking between networks is done. It's very, very easy to set up. Hope you've basically learned something in this part of tutorial. And the next part, I'm going to show you how to configure switches and routers by the CLI, which stands for command line interface way, which is more of the technical way. You'll basically be asked to do this way regardless, and most likely you'll be doing this instead of the terminal. Sorry, instead of the interface, because it's more technical and it's usually the companies prefer that way. So see you later in the next part.